So you were assigned net external force problems right here, and this video is going to go over how to solve these problems. So we're going to solve number one first. So you have this situation here in which the man is pulling his dog, and it's not going directly this direction. It's going a little bit at an angle. And so we're going to have to break this force down into the x and y components. So essentially we have the dog, and we're going to draw the dog as just a box for our free body diagram. And we have a force going up and to the right. That's just how I've drawn it. It doesn't have to be that way. You can see that it has an x component of some magnitude because it's going at an angle of 30 degrees above the horizontal. And it has a y component of some magnitude. And this is the overall vector right here. So to break this vector down into its x and y components, the x component, since it's adjacent, is going to be f cosine theta. And the y component, since it would go over here, and that's opposite of our angle, that's going to be f sine theta. Our force was 70 newtons. So 70 cosine 30 and 70 sine 30. When you plug that into your calculator, 70 cosine 30 is 60.62, so about 61 newtons. And 70 cosine 30 is about 35 newtons exactly. So in number two, you have a crate that's being pulled. So if we draw a free body diagram for this crate, it has a force going to the right of 82 newtons, to the left with a larger force, so I'll make it a little longer, of 115 newtons, upward with a force of 565 newtons, which should be longer than this, but I ran out of room, and downward with a force of 236 newtons. I'll make that one shorter. So if I find the net force in the x direction, remember this little sigma means the sum of the forces in the x direction. So I have this bigger force of 115 minus my force of 82, which gives me a net force of 33 newtons, and that's going to the left. If I sum up my forces in the y direction, I have 565 newtons up, 236 down, so I'll subtract them. And that leaves me with an overall force of 329 newtons. And again, that is going up. So overall, I have a force on this that is going up and to the left when it's pulling on that box. So I'm going to find this angle here and this net force. And again, we've summed our forces in the x and y direction, but now we need to use trig to figure this out. We're going to put them back together into one overall force using Pythagorean theorem. And so we'll do the square root of the x portion squared plus the y portion squared, and that gives us 330.65, which is about 331 newtons. And the angle that that is in, we have opposite and adjacent, and so we're going to go ahead and use inverse tan of the y over the x. The y portion is going to be your opposite. The x portion is your adjacent. So we'll do the y over the x, which gives us 84 degrees. It's this angle here, so that's above the horizontal. So our answer here would be that we have a net force of 331 newtons at an angle of 84 degrees above the horizontal. You could specify above the horizontal to the left if you wanted to. So for number three, we have an apple that's falling out of a tree. The force of gravity is 9.25 newtons, but it also has this force of the wind that's blowing it to the right. And That's 1.05 newtons. So we're looking for the magnitude and direction of the net external force on the apple. So we have a rightward force and a downward force, and so we're going to put those back together into one overall force. The apple is going this way. We're going to put that together into an overall force using Pythagorean theorem. So we'll do the square root of 9.25 squared plus 1.05 squared, and we get 9.31 newtons. We need to know the angle. And as long as we keep this with the horizontal, then it continues to be the y portion is over here on the opposite. So inverse tan of y over x. The y portion is the force of gravity, so it would be the inverse tan of 9.25 over 1.05, which gives us 83.5 or 84 degrees below the horizontal. So our answer there would be that we have a net force of 9.31 newtons at an angle of 84 degrees below the horizontal. So in example 4, you have a sailboat. The water is pushing it to the west, but the wind is pushing it to the north. And again, you're looking for the external force. So in free body diagram form, we'll just draw our box. We have the wind going to the north and the water going to the west. Notice the wind is pushing a little bit harder than the water. So that means the boat's going to end up going a little bit further north than it does to the west. We're going to put those two back together using trigonometry, because we're looking for this. We'll keep with this particular angle there as well. F net is going to be 452 squared plus 325 squared. And then take the square root, which is 556.7 or 557 newtons. Again, the inverse tan of the y over the x, the opposite is going to be this portion, so the y portion. 452 over 325, which is about 54 degrees. So my answer is that I'm going to have a net force of 557 newtons at 54 degrees. Now for this one, we actually know that this is going north and this is going west. So we wouldn't use above the horizontal. We can specifically say that this is some angle north of the west line. So 54 degrees north of west.